Okay, please look at the screen. Yes, okay. We want to change it to base 10. Yes? Because I want log base 10. Okay, so this gives me log 5 divided by log 8. Then I am aware that you don't know what to do with the numerator, but do you know what to do with the denominator? What shall we do with the 8? Divided by 3 log 2. And log 2 is given to be n. Okay, so this is log 5 divided by 3n. But the problem is with the log 5. So I told some of you, how can I rewrite the 5 in terms of numbers that I prefer? In this case, there are some numbers which are relevant. Okay, what is the base over here? Base is 10. And then in the question, what did they give you? Log base 10? 2. 10 and 2. Does it allow you to do something? 10 divided by 2. Okay, let's try that. Log 10 over 2 divided by 3n. Okay, does this actually help us? Look at the board. Quotient law, where's my quotient law? Ah, okay, the one in purple. So when I apply the quotient law, what do I get? Hey, stop saying LG lah, it's log 10 minus log 2 divided by 3n. Okay, what is log 10? 1 minus n over 3n. Rishi, was this how you did it? Okay. Now your turn to try part C. Okay, since you all are not interested, right? I see that you're not really trying. I'll just show you the answer. And I shall not do part D because some of you are not interested in doing it. So I don't want to waste time already. I'll just teach. Yes? No, but not everybody is interested. If you're interested, you can find out. Yes? Okay. I hope this answers your question, Cosby. The next part is on chapter 4.5. Equations. We're going to deal with equations now. And I'll introduce you with this. A to the power of 10 equals to A to the power of x. What does this tell me about x? 10. Okay. B to the power of 3 equals to 4 to the power of 3. What does this tell me about B? Huh? 4. Easy? Easy so far? Because just comparing only, ma. Okay, how about this? Log 5p equals to log 5, 8. What does this tell me about p? Okay. Next, log 3p equals to log qp. Okay. No. Let's change this to 5 and 5 over here. What does this tell me about q? Okay. Quite intuitive, right? Common sense, right? So this is where we have the next law. The next thing that we need to know. Log AP equals to log AQ. If we have this condition, then you should be able to conclude that P is equals to Q. Make sense? Yeah. It's almost like I don't even have to introduce it to you because you know it, right? Okay, that's what this topic is about. Let's try. Let's see how this can be applied. Work example 23. Without looking at the answers, this is the question. Log base 3, 1 minus x, plus log base 3x plus 5 equals to log base 3x plus 11. You are supposed to solve it. In mathematics, when we ask you to solve, we're asking you to find for the value of x. So how do we go about solving this? If I want to do it without skipping step, what is my first step? Log base 3, 1 minus x, x plus 5 equals to? Okay, which law are we using? Product law. Okay, so this must therefore imply that is this an equation that you can solve? Yes, I'm sure you can do it. It is quadratic. So there are a few methods to solve quadratic. You will get x equals to -1 or x equals to -6. You need to show me the intermediate steps. Okay? Now with this information, do we accept both? We need to sub in, yes. Okay, so sub x equals to -1. Then we see that log base 3, 1 minus -1 is 2. Okay, log base 3, 2. Is this a valid logarithm? Yes. It's valid, okay. Then plus log base 3, 5 minus 1, which is 4. Is it valid? Yes. Yes, it is. Okay, then on the other side, this is the left-hand side. Right-hand side, we get log base 3. 3 times -1 is -3, plus 11 is 8. Also valid. Then we can see quite clearly that left hand side equals to right hand side by the product rule. Okay? Now we try x equals to -6 sub. So left hand side, I get log base 3. Left hand side -6, right? So 1 minus -6 will be 7. Then I have a plus log base 3. -6 plus 5 is -1. Oh, sorry, -6 plus 5, so that's -1. Is this valid? Can I take log of a negative number? Can or cannot? Cannot. You can test it out for yourself. Just key into your calculator. LG. I know it is a base 10, but you just put in any negative number. You see that it doesn't work. It cannot. For reasons that were already mentioned in 4.1. Okay? Covered before already. We said that it cannot be. So this one is undefined. So we have to reject this. Alright? Now please try practice now 23. Solve the equation log base 2 x plus 11 plus log base 2 x plus 4 equals to log base 2 5x plus 23. X plus 11 multiplied by x plus 4 equals to 5x plus 23. This is the quadratic equation that you can solve by yourself. You will end up with two values of x again. Can somebody give me the two values of x? -3 and? Are both acceptable? No. Which one is rejected? Okay. You don't need to show me the process of rejecting. You just need to tell me which one to reject. Okay? Okay, next. There is another method to solve the same question. So if I have the same question on log base 2 x plus 11 plus log base 2 x plus 4 log base 2 5x plus 23. The first method that we learned was to compare. Once the bases are the same, we can compare the value in the log. Now I'm going to teach you the second method. You are expected to be able to use both during your test and examination. Okay, first step is still the same. We're going to apply the product law. Log base 2 x plus 11 x plus 4. Then I'm going to move this over. I'm going to move it over by subtracting. So this will be minus log base 2 5x plus 23 equals to 0. Okay? I'm going to apply my quotient law. Log base 2 x plus 11 x plus 4 divided by 5x plus 23 equals to 0. What does this imply now? Log base 2 something equals to 0. What does all this imply? What is equal to 1? That fraction equal to 1? Because of that what is on the board, right? That special result. So if I were to derive it, I actually have 2 to the power of 0 equals to x plus 11 x plus 4 divided by 5x plus 23, correct? I'm just converting from log to exponential. And this is actually equal to 1. What this means is that x plus 11 x plus 4 equals to 5x plus 23. And then it's the quadratic again.
So can we explain from the log 2 there?
From here to here?
Yeah.
I am converting from log to exponential form, where we have our a to the power of m equals to x, for example. So m equals to log base a x. Converting.
Then why suddenly cancel?
Because 2 to the power of 0 is 1.
Oh.
Can? Now, and we see that I get the same exact quadratic equation. Which method do you prefer, first or second? Because it's faster?
More confident.
Okay, sure, go ahead. But you need to do both lah. You need to know how to do both. Alright? So let's go to practice now 24. Try by converting it to exponential. Part A. 2 log x equals to log 2x plus 30 plus 1. We just... Right, I'm going to start on this. When I see 2 log x, I immediately want to put a 2 back to the power for x. Okay, so log x square minus log 2x plus 30 equals to 1. Yeah, I can do this, or log x square minus log 2x plus 30 minus 1 equals to 0. Okay, these are the two options. So for the first one, I get log x square over 2x plus 30 equals to 1. Okay, it's just a combination of our two logarithms using the quotient law. So next step, log something equals to 1. Log something equals to 1. What does the information on the board tell you? Log something equals to 1. Log something equals to 1. Look at the board. Where is the part about log something equal to 1? What does it tell you about the base and that value? They must be the same, right? Because log AA equal to 1, right? You can just chant this. Log AA equal to 1. Log AA equal to 1. When you see log and then the answer is 1, the two values must be the same. So there's actually a 10 over here, isn't it? Which means that 10 must be equal to x squared over 2x plus 30. This is one way of looking at it. The other way is, since logarithm is dealing with the powers, convert it to our exponential form. 10 to the power of 1 equals to x squared over 2x plus 30. They are the same thing. So this is going to be quadratic. You work out the answer yourself for x. Now in blue color, here I have log x squared minus log 2x plus 30 minus log 10 equals to 0. So I get log x squared divided by 2x plus 30. Then I divide it by 10 again. Equals to 0. Then you can solve it yourself again. Alright? Any questions? This one? Because I want to make this side 0. You have an option of making it 0 or making it 1. Because of the two properties over there, log AA equals to 1. And the other, log A1 equals to 0. Yeah. So I get y equals to 9. What is log 4 for? 1 over y. So I still get y squared equals to 9. Okay. Then y must therefore be equals to plus minus 3. So you substitute it back inside to solve for your answer. Log base 4x equals to 3 or log base 4x equals to negative 3. Okay, then you work it out. As compared to, in this case, I will get log base x 4 equals to plus minus 1 over 3. Log base x 4 equals to 1/3 or log base x 4 equals to negative 1/3. Do you see the parallels between this and this? Do you see the relationship? How the base and this value over here, they are swapped. X and 4, they are swapped. So our final answer is also swapped. You get it? Instead of 3 and negative 3, I get 1/3 and negative 1/3. So that is the relationship for the change of base formula on the board. Okay? So for this one example is enough already. We're going to solve exponential equations using logarithms now. So let's take a look at practice now 26. Part A. If you are told to solve e to the power of 2x plus 3 equals to 6. Obviously, I want to solve for x. I want to find the value of x. When my unknown is in a power, you need to compare the bases. Right? That's what I taught you at the start for Emaths. But in this case, there's no way you can make the bases the same. So we need to use our logarithms. Then you have to choose. I want to introduce logarithms to both sides of the equation. Do you want to introduce ln or common log? Ln. Why ln? Because there's the e over there. Yeah, okay, so I listen carefully. I take ln on both sides. My working is going to look like this. Ln e to the power of 2x plus 3 equals to ln 6. Are you happy to see this?
Yes.
Why?
Log e means log e.
This one can bring down, right?
Yeah.
Then this one becomes 1, right?
Yeah.
Then this one calculator, right? Yeah, that's it. So my working looks like this. 2x plus 3 multiplied by 1 equals to ln 6. 2x equals to ln 6 minus 3. X equals to ln 6 minus 3 over 2. Ln 6 is just a number that your calculator will give you. No need to be scared of it. You can get the answer. And as always, check that your answers are valid. Can? Okay, then I shall show you part C. E to the power of 2x minus e to the power of x minus 6 equals to 0. Okay, now how?
Introduce both sides.
Introduce both sides, so like this, ln e2x minus ex minus 6 equals to ln 0.
Yeah.
Does it help you?
Then you can just do quadratic equation of this.
Huh? Move 6 to the other side. Okay. Can you take your calculator and press ln 0? Cannot.
No.
Cannot. Okay, so this is not going to help us at all.
So move the 6 over.
Okay, so e to the power 2x minus e to the power x equals to 6. Then you want to take ln on both sides?
Take ln both sides.
Ln here. Then this one, calculator can give me. What about this?
X divided by x.
How?
E2x minus x.
e2x minus x?
No, cannot.
Are you confusing your laws of indices with those for logarithms? What do you intend to do over here? What can you do? Same base? What is the base? Is it? Can we use quotient law here? Are you sure we can? Look carefully at the quotient law on the board. What is the format? It is log something minus log something. Then you can combine. Do I have log something minus log something? No, I have log something minus something. They are different. Can I expand? Also cannot. This doesn't get me anywhere. Okay, now I show you another approach. Let y be equals to e to the power x. What happens if we do this? Y, what's the power for y? Square minus y minus 6 equals 0, right? Then it's quadratic, you can do it. Y equals to something or something. X equals to something or something. Decide which one to reject. Can? Yes, you can use quadratic formula, but subsequently you must find the value of x. Okay, you are not solving for y. You are trying to solve for x. Yeah, you can. You are saying that this will be your working, is it? E to the power x square minus e to the power x minus 6 equals 0. And then you do a quadratic. Yeah, you can. So you skip let y equals to step. I'll now give you our homework questions. All right.